Hey guys, what's up? This is JRP77 from JGN Games, and in this tutorial we're going to be talking about the Decimate modifier. So the Decimate... So sorry if my voice sounds a little bit weird today. I don't know why. I haven't been yelling a lot, but for some reason my voice just sounds like this. So I can't do anything about that. Let's just go ahead and get started. So decimate means to kill, destroy, or remove a large percentage or part of. And that's what we're going to be doing today. We are going to be talking about the decimate modifier, which allows you to take away vertices off of a mesh. So what we're going to do is we're first going to delete this object by hitting X and then clicking delete. And then I'm going to hit Shift A and I'm going to go mesh monkey. Now this monkey right here, it has a couple vertices, but it doesn't have that many, so we're going to add on to that. So I'm going to hit tab, and now on this side right over here you can see that we have a bunch of different options. I'm just going to click this subdivide option right here, and I'm going to click it 3 times so that we have a bunch of vertices right here. Now notice that there's not that many vertices here, and it actually did a pretty poor job with it as far as making it a more detailed mesh. So I'm going to hit tab now, and I'm going to go over to this right side. I'm going to go over to my modifiers tab by clicking on the wrench, go add modifier, decimate. You'll notice, first of all, nothing really happens, and that's because we haven't changed any of our options. So let's just go ahead and let's talk about the different options. First of all, we have these 3 options up here. These are going to be our different decimation modes. We have collapse, unsubdivide, and planar. So basically what collapse does is it merges the vertices together based off of the shape of the mesh. So this allows us to merge vertices together rather than just flat out get rid of them. So there's a really nice text right here that shows us how many faces we have. We can currently see that we have 32,000 faces with this one object. Now for an object like this is way too much. We probably want to get this down to around 1,000 or so. So let's start playing around with these different options. First of all, we have ratio. Now this is going to be the ratio of the faces to keep or delete. So at 1, the faces are going to remain unchanged. At 0.5, half of the faces are going to remain, and at 0, most of the unnecessary faces are going to be removed. So you can see that if I start changing this, I can just start taking this number down, and around 0.5, you'll notice that we've already killed off about 12,000 vertices. Now it's not exactly half, but the entire idea of this is that it's getting rid of vertices that it sees fit. So we can take this all the way down to as low as we want. We can get all the way down to 7 faces. Now we don't want that. Now you'll notice my computer is starting to slow down a lot, and that's because this is a pretty complex operation. I'm going to put this around 0.25 or so. And notice we have 11,000 faces. Now this is still a lot, so we're going to take this all the way down to 0.1. 5,000 faces is still good. You can notice that we're starting to lose some of these vertices up here, as you can see by these weirdly shaped vertices. I'm going to take this all the way down to 0.05, and that's going to put us at 2,913 faces. And I think it keeps most of the detail intact. Now obviously this is a pretty poor example because what we did was we just added more vertices instead of actually making it a more detailed mesh. So if you had a more detailed mesh, we'd have a more interesting example, but for the reason that I don't have the time to make a really nice looking model, we're just going to be using the monkey. So that's the ratio. It just changes how many faces are kept and deleted based off of a ratio of faces to keep and faces to delete. Then we have vertex group. Now vertex group allows us to group vertices together and then decimate those faces instead of affecting the entire mesh. So what we're going to do is we're going to go and create a new vertex group by going over to our mesh tab, and I'm going to click vertex group and I'm going to create a new one. I'm going to triple click on this so that we can highlight all the text, and I'm just going to rename this to monkey thing. Now what we're going to do is we're going to hit tab and we're going to hop into here. Now you can see that we have a bunch of different options and that we had just bar right here. So what we're going to do is we're going to hit A and we're going to move up to the top of the head, and we're just going to hit B and we're going to select the top of his head. So like right here. Now what we're going to do is we're going to click this assigned button right here. I'm going to click on that, and now that we have that, we can hit deselect and then select, and you'll notice that our vertex group now is selected. So now what we can do is we can hit tab, and then we can hop back into our modifiers tab, go to vertex group, select monkey thing, and you'll notice that only the top of his head is being affected now. And you'll notice that some of the faces still exist, and we actually have 44,000 faces because it had to make new ones just so that it could compensate for this up here. So we take this up to 0.5. You'll notice that it doesn't get rid of any faces because it's only messing with this part up here. So you can notice at 1 that we have the regular amount of faces, but as we start taking it down, you'll notice that more faces are actually added because it has to compensate for this area right up here. Now granted, again, this is a pretty poor example, but that's basically what it does. It allows you to select an area of a mesh and then decimate the vertices from there. Now factor determines how strong the vertex group is. So we could take this down to 0.5, and at half the strength, it would start affecting the vertices on the outside of it a little bit as well. Now honestly, I don't know how this works. I tried to research this variable and I could not figure it out, but that's what I understand it does. It's the factor of how the vertex group affects the modifier. We're just gonna leave this at 1 for now. Now triangulate basically just allows the faces to be triangulated so that we can get rid of some of these faces up here. I don't know how well you guys can see it, but there's actually a couple faces on top of one another right up here in this vertex group. That's a problem because we don't want that. That means that there's more vertices being drawn than are actually being seen. So we can click triangulate, and you'll notice that it does add more faces, but it should also yield you some better results. Now again, for example, it left the square on the top, but that's simply because it's this nature of how we did our mesh. So now that we've got that, we can go into symmetry. Symmetry allows us to make this mirrored over an axis. So if I click on this right now, you'll notice that everything becomes mirrored right here. And again, this can yield you better results, especially if you have a symmetrical mesh like this. If you have an asymmetrical mesh, this may not work as well. So we can go over here to this little drop down, click on this, and we can select an axis. We can do X, we can select Y, we can even select Z. But because most of our faces are being decimated on the X, that's why X is the one that seems to work the best. So that's the collapse side of the decimate modifier. So with that out of the way, let's just go ahead and hop into the next mode, the unsubdivide mode. Now the unsubdivide mode is the opposite of subdivide, which is what we did earlier. And basically what it does is it just removes subdivisions to make the mesh more simple. So what we did was we subdivided our mesh at the very beginning by clicking that big subdivide button. What this is going to do is this is going to unsubdivide that mesh. Now the iterations is our only variable, and this is going to be the amount of times that the action is going to be performed. At 0 iterations, nothing's happened. But you can see as we start to move up that the mesh starts to become a little bit more jittered. At 1 it starts to become a little bit jittered, but if we move it up to 2, then you'll see it starts becoming flat. Now you may be wondering, why is it so jagged on 1 and it's so smooth on 2? And that's because of some math that Blender has actually incorporated with this. They said that 1 subdivide requires 2 iterations. At least that's how their math and their algorithm works when decimating their things. So if we do this, you can notice that 3 will always be this jagged one, and 4 will bring it back to where it should be. Now you notice with 4 iterations, we've already gotten down to about 5,400 faces. We can go all the way up to 5, make it even less detailed. This is about where we had it earlier. We can keep going even. We can go and make it even less detailed. We had about a couple thousand faces earlier. This is what we had at the beginning, but you can see that the algorithm works generally pretty good. So that's basically all there is to it. You just select how many iterations you want and the modifier works for you. Now, as a game developer, I use this the most because this allows a quick and easy way to unsubdivide your mesh and get rid of some of those unwanted vertices. It works especially well within our scenario. We have a bunch of vertices over a very small space. So you can see right here, if I hit tab, we have a lot of vertices right here, but it's just a flat face. This works really well whenever we start doing this because it gets rid of all of those vertices in here. Now you can't see them right now because you have to click this big apply button before it works, but we're not going to be worrying about that. We're just going to keep working with the modifier. Now let's head on over to the third and final method, the planar method. The planar modifier reduces detail in forms with mainly flat surfaces. So this is very useful for stuff like what we're doing, where we have these giant flat sections over the top of our head. And you can notice that's already worked a little bit for us. And you'll notice that it keeps the detail in these more complex parts of our mesh, like the nose and in the inner ear and the eyes. So we got a couple variables for this. Let's just go through them real quick. Then we have the angle limit. Now this is going to dissolve the geometry that's on an angle lower than the angle set. So if we have 5 right now, anything that's lower than 5 degrees from another vertex will be decimated. So you can see that 5 right now, we can bump this up, and you'll notice the farther we go, the more faces start to go. So we can set this all the way down to 0, and all the faces would remain. But 5, 6, around that, it starts getting rid of these faces on the back of the head where there's these giant flat sections. But you'll notice that it still keeps these curves right here. So this is very useful, again, for getting rid of vertices. Then we have all boundaries. Now what all boundaries does is it allows us to delete the vertices along the boundaries of faces. And this gives nicer results when using a higher angle limit. So we can set this up to something like 45, and you'll notice that a bunch of things right here are deleted, and the mesh doesn't look that good. If we select all boundaries, you'll notice that it starts to fix some of them a little bit, even though this still kind of looks like a Van Gogh painting. It starts to combine some of the faces together to give a better result. And you can notice that this doesn't really do much if we put this on, let's say, 5 again, is it just gets rid of a couple of those faces that actually didn't get deleted. Then we have delimit. Now these are 5 different options that we have for preventing the action from happening on certain areas of the mesh. So we have the normals. This mode allows the modifier to only be applied to normals that are facing this way. All right, so here's the deal. I didn't like the way I explained this. I'm gonna try to explain this in a little bit of a better way. So think of it like the vertices on a cup. So on the outside of the cup, these vertices facing towards you, the label, those are going to be the normals that it's going to affect. Then there's the normals on the inside of the cup. So inside the cup is where the water actually is. So anywhere where the water is being held, that's where it's actually going to be. And those where the normals are transparent, because you don't want to have a completely solid flat top to the cup. You want there to be a hole in the cup. So by the normals being down on the hole of the cup, then basically you can see inside of the cup. That's what I'm meaning by the normals. Hope this clears things up just a little bit, because this was a really poor explanation. And yeah, let's just get back into the tutorial. Then we have material. And what material allows us to do is material allows us to prevent the modifier from dissolving faces on the borders of faces assigned to different materials. So let's say that we had one material for the top of the head, and we had one material for this square right here. Then the first material, that was our default material, would get decimated, but the one with the different material on it would not. And then we have seam. Now what seam allows us to do is it doesn't dissolve the faces with edges that are marked as seams. Now this is very useful for UV mapping. So if you don't know what UV mapping is like applying a texture onto your object. It's like applying something like an image around an object, and it gives us all the coordinates to do that. So seam, you can make seams to make different sections of your mesh that you would use for unwrapping it. So the seams, in this case, would not dissolve those faces, and it would leave that sharp line right there. Because you can see that if we take this back to normal, we turn the angle limit up, you can notice that some of these lines start disappearing. Basically what it does is it doesn't get rid of those lines. Then we have sharp edges. Now sharp edges allow you to smooth out a mesh and make the edges sharp. So this is a pretty poor example, and I don't really have any places I could do this except for the eyes, but there's a way that you can hit tab, and then if you hit space and search sharp, you can do mark sharp, and what this allows us to do is set a sharp edge. So because we have so many vertices, I'm not going to go into it now, but let's just say that we selected all of these vertices up here. We selected all of these, and then we marked that as a sharp edge. Then when we hit tab and we go over to smooth, this edge would remain sharp and the vertices wouldn't be rounded off. Think of it like you have sandpaper and you're going to sand off every edge, but then you see a little sticky note on one of the edges that says do not unsharpen me. That's basically what sharp does, is this allows us to keep sharp edges and not get rid of those vertices. Now UVs, I have been looking and I have been unable to find any information about this around the web. So if you have any idea how the UV part works, please let me know in the comments down below. It would mean a ton to me, but I've researched the UVs over and over and over again, and I cannot seem to find an answer. So that's basically all there is to it, guys. This is the Decimate modifier. It allows you to unsubdivide your mesh and make lower resolution versions for your game, for something like occlusion culling, or for just to make your game more optimized. This modifier is great for this very reason. So thanks for watching, guys. I hope you guys liked this tutorial. If this video sucked, then you know what to do, but if it didn't, drop a like, and don't forget to subscribe for more content. Don't forget to check out our website, social media, and merch, as well as our community Discord server. All of those links will be in the description below. Thanks for watching, guys, and I'll see you guys next time.